stack-based implementation of preorder traversal. The implementation of recursive procedure for traversal of binary tree is simple. However, in the recursive algorithm, the underlying procedural steps are not visible. An alternative approach is to use an iterative procedure, which is intuitively more clear. In iterative procedure, we would need to descend and ascend to different parts of the tree. The address value contained in each node enables us to descend to right or left subtree. The iterative procedure is essentially stack-based. The algorithm for preorder traversal of a tree in iterative way is: Number 1. Push the address of root to stack and assign current node pointer P to the root. Repeat step 2 until P is not null. Number 2. Proceed down the leftmost subtree rooted at P. If there is any right node on the way, push its address onto the stack. Continue processing the nodes until the leaf node is reached and processed. Number 3. Pop the stack and assign the popped address to current pointer P. If P is null, exit. Otherwise, perform step 2. Let us consider an example of application of iterative procedure for preorder traversal. This figure depicts a sample tree. Steps are summarized as: Process A, push C, process B, D, pop C, push F, process E, push H, process G, pop H, pop F. Finally, the preorder traversal is A, B, D, C, E, G, H, F. The code for iterative procedure for tree traversal is substantially more complex than the code for equivalent recursive procedure. In the former case, we have to deal with 3 classes representing tree node, stack, and tree structure. The interface for these classes are as shown. Here, B-tree class includes methods CRBT and BT to construct a binary tree. It contains stack preorder method to traverse the tree in stack-based preorder. Stack class utilizes an array of node objects to hold node data and pointer addresses. It contains push and pop method for storing and returning node data from stack. Code for the stack preorder method in the B-tree class is given in the demonstration. Stack-based implementation of Inorder traversal. We can implement the iterative procedure for Inorder traversal of a binary tree by using a stack. The algorithm based on the iterative procedure is: Number 1. Assign current pointer P to the root of the tree. Repeat step 2 through 3 until P is not null. Number 2. Proceed down the leftmost rooted at P, pushing onto the stack addresses of a node on the way. Number 3. Pop off the stack and process the pop node. If stack is empty, then exit. If the pop node has a right child, assign current pointer P to the right child and perform step 2. Let us explore how the algorithm can be applied to traverse a tree. Figure shows a sample tree. We follow these steps to traverse in order. Push ABD, pop DBA, push CEG, pop GE, push H, pop H, pop C, push F, pop F. Finally, the in-order traversal is DBAGEHCF. The implementation of the iterative procedure for in-order traversal uses the set of classes called node, stack, and tree structure, which we presented in previous section. For the in-order traversal, we use a method named stack inorder. The code for this method is shown in demonstration. Stack-based implementation of post-order traversal. The iterative procedure for post-order traversal is more complicated than the pre-order and in-order procedure presented earlier. Here, we have to save addresses of a node and its associated child. After popping a node, the right child are handled differently. In order to make a distinction between left and right child, we use some special symbols, say $, which is saved with the address of the right child. The algorithm for post-order iterative procedure is: number 1. Assign a current pointer p to the root node. Then repeat step 2 to 3 until the stack is empty. Number 2. Traverse down the leftmost path of the tree root at p. At each node, push the address onto the stack. If there is right child, push it to the stack by flagging with $. Continue until the leaf node is reached. Number 3. Pop and process all nodes which do not have the flag $. If the stack is empty, exit. If a node with $, flag is popped, remove the flag and assign current pointer to the right child. Perform step 2. Let us see how this algorithm is used to traverse a tree in post-order. Consider the tree shown in figure. The necessary steps for traversal are summarized as: push A, $C, B, D. Pop DB, pop $C, push C, $F, push E, $H, push G, pop G, pop $H, pop HE, pop $F, push F, pop FCA. Finally, the post-order traversal is DBGHEFCA. In order to implement the post-order iterations, we need to modify the node class to include flag, which can be $, for a right child, and space otherwise. The new class structure is shown in figure. It is renamed as snode to make a distinction. The code for implementing the post-order procedure using a stack is shown in demonstration.